Create new program. Okay, so signal pattern detector. First plot. They heard a noise from the garage, but it turns out it was nothing. So now that I have plenty of free time, I might as well get back to this. Keep my skills sharp while I look for a new job. Okay, so he lost his job. He's hearing things from the garage where this computer is. Is this computer like alive? Is this computer like some evil creature or entity? That doesn't seem... This doesn't bode well for us. Okay, so read a value from in. Look for the pattern 0, 0, 0. Write 1 when the pattern is found. If not true, write 0 instead. Okay, so I want to read 3 things in. Oh, interesting. Okay, so I want to read 3 times in. If all 3 are zeros, then we're good to go. Maybe just one thing, the number of zeros so far. Yeah. Oh, yeah. What if we do that? What if we just take a 0, and if it's a 0, we move 1 down, and then we just add 1 to it, and if by the end it gets to a 3, oh, is this modulus? This is basically modulus. If it's a 1, I just add 1 to it, otherwise I reset it to 0. I don't have to like do a full like implement modulus. I don't think so. So if we take you, if you're okay, so what if I just do this? If you're a 0, I then move 1 down. So we'll move up to, apparently we don't need the comma. So move up to ACC to our accumulator. We are going to check to see if you're 0. So if you're equal to 0, jump to 0. Otherwise, I move 0 down. So I guess like move 0 down, jump to start. So on 0, we're going to move 1 down, and then it jumps to start automatically. The output column shows that any sequence of 3 zeros is valid, even, yeah, exactly. So what I'm thinking here is that I just, okay, we're going to have to start. We add up to the accumulator here. Now, I kind of want to check to see if is that true? How do I want to do this? Okay, move 0, we move 1 down. Okay, so I just want to... Yeah, any non-zero will reset the count. That's pretty easy, right? if I add up, okay, so if I add, do I want to check to see if you're a 0 or an up? Yeah, how do we count in the first place? If you're a 0, I want to reset, or I want to reset to back to 0. So it's not, if it's not just adding it, I want to reset it. So if I move up to ACC, and then if we have a 0, you can move 1 down to add or move 0 down to reset. So yeah, so here's 0 down to reset, right? So if you're a 0, okay, so if you're equal to 0, we reset. And reset means I want to move 0 to ACC and save. And that's it. And then also we're gonna have to move ACC down and then jump to start. If we're not equal to 0, then I want to add ACC. No, I want to, I need to restore from backup to whatever. Because, okay, I need the count. I need the count. I could use one of these too as sort of like a state to like send something over there. Okay, so basically move up here, check to see if it's a 1. If it's equal to 0, then we're resetting. And reset means we just, I don't have to move 0 to AC because we already know that you're equal to 0, right? So we just save that to reset the backup. And then we also just move this down because you need to be a 0. And then jump back up to start again. If you are not 0, I want to add you again, which means I need a temporary storage here, which we can use over here. So we can just move up to ACC, move ACC left. So we'll just store that really quickly, and then we check to see if we're resetting. If we're resetting, we're good to go, and we come back up to here. If we're not resetting, we want to jump to look for pattern. So we're continuing to look. I want to add. Now I moved up to ACC, so really I want to swap and add left, which means I need to now move ACC right, but then I need to drop this. So before I do that, we're going to move left to nil. We add left, and now I need to check to see, I guess like now we're running out of moves. So let's now just move. Let's move ACC down. Let's add left, move ACC down, and then let's also save to save our backup. So now we're going up. Okay, so I run out of space, which is okay. Down here, we're just going to get a number. It's either going to be 0 or it's going to be 3 or 6 or 9. So I kind of want to implement modulus here, don't I? So if I subtract 3 and you're still above 0, I want to continue trying to subtract 3 until eventually we get 0 or below 0. Why 3, 6, 9 and not 4, 5, or 6? So, wait, is that true? If I add left the number of zeros, oh, you're right. So, oh, okay, this is gonna be the number of zeros that we've now gotten in a row. Oh, and it's really just the last 3. Okay, yeah. So if I subtract 3 from this, so if I move up to ACC, if we sub 3, if we are greater than 0, we jump to greater. In greater, we're going to move 1 right. If it's not greater than 3, then it's less than 3. I probably want to... Do I want to reset it, or are we just good to go? So here, this is like 0. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then that starts at 0 again. But I'm moving that down here. Okay. So then, okay, if this is greater, okay, we do that. Otherwise, it's just 0, right? So otherwise, move 0 right, and then jump relative. It's like JRO, -4. I don't like it. And then that goes back to the start. Well, I have my accumulator up here, don't I? So this is the accumulator that is looking at zeros. And if it's ever less than 0, if it's ever a not 0, it resets. So this is the accumulator. And then this is just checking to see if the one that's moving down is, we have had more than 3 zeros at a time. Okay, I think we're fine. So we move you right, and then all I want to do is I just want to move left down. Oh, that's really close. Okay, so most of it is working. So this one is, we got 3 zeros in the first place and we got 0, but then everything else is working. So this feels like an off by 1 error. Yeah, off by 1 error. All right, what did I do wrong here? I do move left nil if we're resetting. Otherwise, I am adding left here. So I am taking both of these. So we get that. We have the 0 coming in. Zero comes in left. Equal to 0. Oh, wait, you know what? Because I do this weird. I do this weird. So move up accumulator. So you're a 2. If you're equal to 0, we're a 0. We're not equal to 0, so move 0 down. I kind of want to do the opposite. I don't like this anymore. So I want to move 1 down and then 0 down. So then move up accumulator. Oh, but you know what? It totally makes sense. Because I'm just adding these. Okay. So if it's a non-zero, we move 0 down to add 0 of that. Okay, so we move up to here. So this is going to be a 0 for the 2. And I move up into accelerator and accumulator. I also move that to the left to store for storage. I then check to see if you're equal to 0, we are resetting. Otherwise, we are looking for the pattern. So I kind of want to adding. So add. Okay, so if we get to here, we're going to swap back to what you were previously, which you're starting at 0. We add left back into here, which was that should be a 1 that we move down. So we add that back in. We move the accumulator down and we save it. So the problem is, okay, 2 comes in. You're not equal to 0, so we move 0 down. What does the move left nil do? It basically takes the output that this is going to give and drops it. It's basically the equivalent of moving to what is it called? Dev null in Unix or Linux-like systems. Okay, so here's our first 0. So we move a 1 down. So here's that first 1 here. But we're still in the resetting from the first 2 that came in. So move left nil. So this 0 gets dropped. We jump back up to start. We move this into the accumulator. Move the accumulator left. So moving over there for storage. We check to see if you're equal to 0. You're not. So now we're going to jump to add. I want to swap you. So the 0 and a 1 come down. We add left, so that becomes a 1. And then we move this down. Now 3 is already in here, and so there was a second one. Okay, so this was that second 0 that came in. So this should be 2, so this is fine still. So really it's after we get that next 0 coming in. So here's the first of the 3 zeros that we're looking for it. Yeah, left to trash, exactly. Okay, so 0, we're about to move the 0 down. We're now waiting for this 0 to move down. We're in the middle of the resetting from the 4. Okay, so move up to accumulator. No, we still, okay, wait. I think we already got the off by 1. Shouldn't 0 be a 1 from top to bottom, not 0? Wait, which one? Shouldn't 0 be a 1 from top to bottom? This is 0 for moving 1 down from here. 0 be a 1 from top to bottom, not 0. When moving from top to bottom on a 0 input, it should be moved 1 to the bottom one. Yeah, okay, so we moved up to the accumulator, so which was whatever the input was. We moved that into here. And then we move a 0 down. We just basically say, okay, move a 0 down. We converted this into we're converting whatever this was into a 0 or a 1 and moving that down. And then giving this, now we're dealing with that. But we're already off, I think. So we've accumulated 1 here. So this is the third 0. And now this is the fourth 0. Okay, so that becomes a 2 here. Okay, so move up. Swap, we have 2, add left. Move accumulator down. Sub 3. Oh. Oh, I need this to be... Oh, shoot. I need this to be equal to 0 or greater. Okay, so If you're equal to 0, greater, and if you're greater than 0, greater. I had a greater than 0 check, not a greater or equal to 0. That's it. Okay. All right. That's a good question. Let's find out. So we have just jump equal to 0, not equal to 0. Oh. We can do less than 0. We can do the opposite way. Yeah, let's do the opposite. So the opposite would be if you are less than 0, lesser. Lesser, so this is going to be move 1 right, jump back to start, move 0 right. There. Same exact stuff, except slightly better logic.